This example will walk us through calculating the mean and standard deviation for binned data based on frequency. Here's the problem. Living in poverty. The following frequency distribution represents the age of people living in poverty in 2013 based on a random sample of residents of the United States. In this frequency distribution, the class widths are not the same for each class. Approximate the mean and standard deviation age of a person living in poverty. For the open-ended class 65 and older, use 70 as the class midpoint. All right, so we can see our table of data highlighted in gray. There are many children, ages 0 to 17, that are living in poverty. And it's very important to notice that our bins are definitely different. So 0 to 17 is 17 years of differing ages. While if we look up at 60 to 64, we only have 4 years. And we should really think about that as 5 years because the next bin starts at 65. So we have 60 to 65 really. The first thing that I did for calculating the mean was to create a new column called the midpoint. The midpoint is where I figure out, with this bin of 0 to 17, what is the middle age? I take the 0, that is the lower class value, and then the 18, which is the next lower class value. I add those together and I divide by 2. That is how I came up with the midpoint value of 9 for the bin of 0 to 17. Similarly, if I look at the 60 to 64, I came up with a midpoint value of 62.5 because I added 60 plus 65. When I divided that by 2, I ended up with 62.5. Now the text of the problem had said to use 70 as the midpoint for this last bin. This next step for calculating the mean is to find the sum of the midpoints for each bin multiplied with the frequency for each bin. And then I divide it by the total frequency of each bin, which really is the total frequency of adding all of these frequencies, which ends up being the total number of people surveyed in this sample. All right, so the calculation for my mean is kind of long, and I'll let you read through that. Essentially what I did is I took the midpoint and I multiplied it with the frequency of each bin. I added all those results together to get the numerator. The denominator is the sum of all these frequencies. The mean calculation ended up giving me 31.9 years. That means the average age of a person living in poverty is 31.9. Calculating the standard deviation requires additional calculations. I take the column with my midpoint values, and now I'm going to need to find the difference between each midpoint value and the mean I came up with. This midpoint value is 9, and the mean I came up with was 31.9. So the difference in value is negative 22.9. I did that for every single bin. Now I take these values, negative 22.9, and so on, square them. And you can see the respective values I came up with. After that, I take this squared value and multiply it with the related frequency. And here you can see the value that I ended up with for each bin. At the very end, I have summed all those calculations, and I also summed the frequency that we had done before. Those two values are needed to determine the standard deviation. I take the value on the far right-hand side of the table and divide it by the sum of all the frequencies. I also subtract 1 because this is a sample. I end up with a standard deviation of 20.9. Calculating the mean and standard deviations of binned data is very time-consuming.
I recommend using StatCrunch or a similar program to facilitate finding the mean and standard deviation with technology. I'm going to use StatCrunch. First, I'm going to select my data. I just use Control-C as I have a Windows system. Since my data had a header, I'm going to click up in the header where it says var1 and paste this. Next, I'm going to modify the bottom row of the age column. I'm going to say this is 65 to 75. That way it has a midpoint of 70. Once my data is prepared, I go to Statistics, Summary Statistics, down to Grouped Bin Data. My bins are my intervals, so that's age. My counts are my frequency. I select consecutive lower limits. That's important. I'm also going to select mean and standard deviation. I did that by using the Control key. I'm going to scroll down and select this unadjusted standard deviation. That is the population standard deviation. When I hit compute, it gives me the mean of 31.9 when I round it, and the standard deviation of 20.9. You'll notice the two standard deviation values are slightly different. The standard deviation value in the middle that says std.dev is 20.911438, which is slightly larger than the unadjusted standard deviation. The unadjusted standard deviation is the one that we use for populations. So whenever you're dealing with a data set that comes from a population, make sure you select the unadjusted standard deviation value. We were working with a sample, so we need the middle one here of 20.9, which matches what we had come up with. Remember, we had a mean of 31.9, and we had a sample standard deviation of 20.9.